Today we're going to talk about complex fractions and how they can deal with rational expressions as well. So the first is, you've probably seen this before, but let's just look at a simple complex fraction if we had something like 1/2 divided by 3/4. Well, the first thing I like to do is always rewrite this. And how we're going to rewrite it is we're just going to rewrite it in the line formation. So if we do 1/2 divided by 3/4. Those two things are equal, right? We haven't changed the expression at all. We've just actually changed how it looks. Well, at this point, this is something we did on day one when we looked at rational expressions is what did we do when we had a fraction divided by a fraction? It was just written a different way here to start. Well, and when that happens, you can just have the first term stays the same, and then we just multiply by the reciprocal, meaning we multiply by what happens if we flip the fraction. Well, now you would just have 4 times 1, which is 4, and 2 times 3, which is 6. And we can then reduce that to 2/3. And so really, these complex fractions, while they might look very intimidating at the beginning, there's nothing really scary about them. We just have to make sure, or I think it's important to rewrite them in that other form, and then we just multiply by the reciprocal. If we look at one that then gets a little bit more complex, maybe we say, okay, well, let's follow the same method that we just used. So 4 over m divided by 4 over 25 minus 16 over 25. And what I would do is if you have more than one term in either the numerator or the denominator, please use parentheses to kind of remind yourself that, hey, these two things are grouped together before I can do the division. So now what we need to do is let's deal with this. And sometimes it's going to be a little bit more complicated than others, but this one's pretty simple to start with. So if I look at this denominator, well, the denominator in the denominator, you can see that those two are already the same, right? So they have a common denominator, 25, meaning I can just do what's in the top. So I can do 4 minus 16, so negative 12 over 25. And we've now dealt with that parentheses, so it's now still divided by 4 over m. And let me change this back to the color that we were originally working in there. So now you can see that's where my denominator comes in here. So now if we have this, we can use, okay, well, 4 over m. Now we're going to change it to multiplied by the reciprocal, 25 over negative 12. And so that would be 100 on top divided by negative 12m. And at this point, we could start to simplify 112. Well, that would go to 50 over negative 6m. I can still reduce by 2, so 25 over negative 3m, which is where we kind of have to stop. So you can see there, yeah, it gets a little bit more challenging, but just deal with the numerator and the denominator separately first before we divide them. So let's look at the last one here. Last one that we're going to do in this video. So in this case, here, again, first thing, rewrite the equation. And it's important, I think, to use the parentheses again to kind of separate the two terms. So divided by, and we'll even do different colors here to try to make sure that we can see the differences. Now that we have those separated, let's just look at the numerator and the denominator separately. So let's look at the numerator right now. So first, we just treat this like a subtraction problem. So the second term, then we could factor that denominator right to x plus 2, x minus 2, because there was a difference of squares. And that would mean us, okay, that we need to multiply this first term by x plus 2 to get that common denominator. So we would have 3x plus 6 over x plus 2, x minus 2. And you see there's a little work, but then now the denominator is the same, so we can just add the numerators, and I just end up with 3x, x plus 2, x minus 2. Now, great, so that side's done. So now let's look at the denominator, like the part that's in red here. So the common denominator, meaning this was going to actually have to be, we're going to have to multiply the first term by x minus 2, and the second term by x plus 2. So I get 3x minus 6 over x plus 2, x minus 2, plus x plus 2 over x plus 2, x minus 2. And so while this might seem a little bit complicated, what you're mainly doing here is we're just doing the same kind of process that we've done in the other lessons when we added and subtracted or simplified, but now we're kind of throwing them all together. So at this point now, it's completely factored. We're ready to do the division part. So now I'm going to switch to all one color because now they're going to be one thing. So 3x over x plus 2, x minus 2, multiplied by x plus 2, x minus 2, over 4x minus 4. And so now we could combine that to become 3x times x plus 2 times x minus 2 over x plus 2, x minus 2, 4x minus 4. Well, we can see that some things are going to simplify here, the x plus 2, the x minus 2, and so I would be left with 3x over 4x minus 4. And from what we've already learned, we also need to remember that we are going to have restrictions here, so x cannot equal negative 2, x cannot equal positive 2, and x cannot equal positive 1. So that could be your answer. You could also see this written as 3x, and we could factor out that 4, x minus 1. That would be another way you could see that written. But the big thing to remember here is rewrite that complex fraction to that from what looks very complex here to the written out form where we can just then multiply by the reciprocal.